Hello friends, welcome to 12th session on numerical analysis of BSc 5th semester. In this session, we will solve one more example on method of false position. The procedure and one example pertaining to method of false position we have studied in the previous session. So the most important thing here we have to remember is the formula. The formula of the regular false method, that is very important. And if we remember the formula and if we find the values of a and b, that is the initial interval in which the desired root lies, then the work is very simple. We can repeat the steps again and again and get the desired solution. So at the end of this session, we will be able to understand thoroughly the method of false position, the steps involved in this method, and we will be able to solve more and more examples on regular false method. So let us consider the next example on regular false method. So here is the question. You please look at the question here. We have to find the real root of the equation. The equation here is this thing, that is x log x to the base 10 equals to 1.2 between 2 and 3. So this is a, this is b. So the initial interval a comma b has been specified in this problem. We have to find out the real root of this equation in this interval correct to 3 decimal places. So these are the things we have to observe from the given data. Now, as usual, we have to collect all the terms on the left hand side. So let us take it to this side. So this is as it is. So 1.2, if we take it to left hand side, it will become minus 1.2 like this. So this entire thing is now just like f of x equal to 0. That is the given equation. So the given equation is f of x equal to 0. So here f of x is this much. So this is the first job we have to do. Next, after having this a and b, as I have told you, if you look at the given problem, this is a, this is b. So therefore, let us suppose a equal to 2 and b equal to 3 in this problem. So this is also the data given. Now what we have to do in the first step, we have to find f of a, f of b. Why to find f of a, f of b? Because they have to be used in the formula itself. What is the formula? The formula of regular false method is here. So we have to use this formula. Therefore we need f of a, f of b. That is, f of a value, f of b values can be obtained by substituting the value of a and b, a equal to 2, in the expression of f of x. In the previous slide we have seen what is f of x, that is log x to the base 10 minus 1.2. x log x to the base 10 minus 1.2, that is the value of f of x. Wherever x is there, if you substitute a. So what is a here? A is 2. So if you substitute 2, you will get the answer as negative of 0.5979. And on the other hand, at b equal to 3, if you evaluate the same expression, you will get f of b, and it is going to be positive of 0.2314. So from this we can say that since f of a and f of b are of opposite signs, we can say that the root is in between a and b. The root is in between 2 and 3, we can say like that. So therefore, after concluding like this, we can use the formula for the first approximation of the desired root, which lies in the interval 2 to 3. That is a to b. So the formula is here, regular false method formula. Substitute the value of a equal to 2, b that is 3, f of b that is here, f of a that is here, and all other values. If you substitute and simplify, the answer is going to be x1 equal to 2.7209. Very simple way you can proceed You can use the calculator, you can simplify the expression on the right hand side, and then you will get x1 equals 2.7209. So this is the first approximated value of the unknown x, which we have evaluated using the regular falsification method, that is this formula. Now, after finding x1, our next job is to evaluate the value of f at this point x1. This is a new approximation which we got. At this point, what is the value of f? That we have to evaluate using the same expression of f of x. And if we do that, we come to know that the answer is minus 0.0172. This is negative. And we in the previous step evaluated f of b, that is f of 3, as positive of 0.2314. Since this is negative, this is positive, and this is negative, we can say that the root is in between 3 and this value. We can say that the root is in between this and this. So therefore, we consider the smaller value as a, that is a equal to 2.7209. We are considering b as the higher value, that is 3. It is here 3, that we are considering. So the root is in between these two, therefore a is to be chosen as this new value, b as it is old value 3, and we have to use the same formula, that is this formula we have to use again, using the same formula with new values of a and the same value of b. If we simplify the right hand side, we come to know that the value of x2 is equal to 2.72402. We can observe in this step, in the first step, we got x1 whose value was 2.72. Now here in the second step, we got x2, that is the second approximation for the desired root, whose value is 2.74. So from the second digit onwards, from the second decimal place onwards, the answer is different. So at the first place, both the answers are correct at the first decimal place, but at the second place itself it is varying. Therefore, we should not stop at this point. We have to proceed. So what is to be done after that? Once we find x2, we have to go for finding x3. Before going to find x3, we have to find out f of x2. So f of x2 is to be found once again in the same way as we have done in finding the value of f of x1. That is, we have to replace wherever x is there in f of x, the value x2. That is, x2 value is 2.7402. So this value, if you substitute this value, when we substitute into f of x formula in place of x, we come to know that the answer is negative of 0.0038. So again, f of x2 is negative, whereas f of x2 means f of 2.7402 is negative, whereas f of 3 was positive. We have observed in the previous case, f of 3 was positive. Therefore, we can say that the root is in between this value and this value. This value and 3. F of this is negative, f of 3 is positive. Therefore, the root is in between 3 and 2.7402. Since this is the smaller value, take it as A, and 3 is bigger value, take it as B. Now, using these two values in the same formula which we have used earlier, that is A f of B minus B f of A divided by f of B minus f of A. The same regular falsi formula if we employ and simplify whatever right hand side we get, the final answer turns out to be 2.7406. So x2 we have observed this much, x3 we have observed this much, and what is our observation? Our observation is up to 3 places of decimal, that is 740, 2.740. and here also it is 2.740. So correct to 3 decimal places we got the answer. That is, we got the root correct to 3 decimal places. Up to 3 decimal places, the two consecutive answers are same. Therefore, we can say that at the value which we obtain at this step, that is at the third iteration, that is the desired solution. So therefore, we can stop at this iteration and we can say that since x2 and x3 are same up to 3 decimal places, we can consider x is equal to 2406, which we obtain in the third iteration, as the desired root. So when we round off, 6 is greater than 5, therefore this number is to be increased by 1. So 0 is to be made as 1 because we want to stop at the third place. So 0 is to be added by 1 because it is greater than 5. Therefore final answer is 2.741. That is the required root of the given nonlinear transcendental equation by using regular falsi method. So I hope you understood the procedure and this particular example based on regular falsi method. You can use the reference book and you can solve more and more examples. And here I am going to give you one assignment problem. Please have a look at that and try to solve it by using the reference book. It is over here. Please try to solve this problem. The question is here and your answer should be like this thing. Please refer the book which is mentioned earlier, that is Numerical Analysis using Mathematics 5C, written by me. Look at this book, try to solve more and more examples with this. Let me stop. Thank you.